Imagine I ask you to guess a cigarette number between 1 and 100. You say 50. I tell you 25. You say 25. I tell you 2. You say 37. 2. You say 43. Too high. Now, here's the question. What is the smartest strategy to find the number as quickly as possible? Believe it is not simple guessing game. It is actually one of the most important algorithms in computer science. And that exactly what the LeetCode 374 trying to teach us. We are given a number n. Somewhere between 1 to n, a cigarette number exists. Our goal is to find the only the help we get is the function called guess. If guess num is equal to 0, we found the number. If guess num is equal to minus 1, our guess is too high. If guess number is equal to 1, our guess is too low. First idea that the most beginner things, let's start from 1, then 2, then 3, then 4, and keep growing up until we find the answer. Sound reasonable, but imagine 2, 147, 483, 640, 647 numbers. We are actually going to check billions of numbers one by one. Definitely no. We need something smarter. Let's go back to our guessing game. Suppose the number is between 1 to 100. What's the smartest first guess? Not 1, not 100, not even 25. The smartest guess is 50. Why? Because it immediately cuts the search space into two heaven. Imagine if 50 is too high, then we know the answer must be between 1 and 49. Half the number disappears instantly. If 50 is too low, we know the answer must be between 51 and 100. Again, half of the number disappears. Pause this video for 5 seconds. Can you guess what the famous algorithm keep dividing the search space into two heaven? It's a binary search, and that's why this question exists. The problem is not about guessing the number, it's about recognizing when the binary search can be used. Whenever you see shorted number, a range, higher or lower feedback, search space shrinking, you should immediately think binary search. Let's play the game. Suppose n is equal to 100. The cigarette number is 73. First guess we made is 50. Too low. Search range becomes 51 to 100. Now guess second guess is 75. Too high. Search range 51 to 74. Third guess we do is 62. Too low. Search range is become 63 to 74. Fourth guess we made is 68. Too low. Search range becomes 69 to 74. Fifth guess 71. Too low. Search range becomes 72 to 74. Sixth guess 73. Correct. We found it. Congratulations. Now, not, notice something amazing. We found the number only in 6 guesses. A linear search might need 73 guesses. Binary search need only 6. Since we already know the strategy, coding becomes straightforward. So let's say this approach inside the code and understand it line by line. As you can see, we passed all the test cases. Let's connect every line with the strategy we just used. The long left one and long left right. Long right equal to n. This represents the range where our search could exist, initially 1 to n, while left is greater than equal to right, as long as there are number left to search, keep guessing. First, middle, uh, we can find. This is the formula for finding the middle term we use here in our code. So this is our next guess. Always choose the middle number. That's the secret of the binary search. In result is equal to guess mid. The game tells us whether our guess is correct, too high, too low. To find the answer, if the result is equal to 0, return mid. If our guess is too high, throw away the entire right half. If our guess is too low, throw away the entire left half. Every iteration removes half of the remaining number. That's why the binary search is incredibly fast. Time complex. Suppose there are time complexity. Suppose there are 1 lakh or 1 crore numbers. Binary search doesn't need to guess that million or billion guesses. It's only need about for million number. It's about 20 guesses. So time complexity become O log n. Space complexity. We only use a few variables, no extra array, no extra data structure. Space complexity is O of 1. And that's the lead code 374. At first glance, it look like guessing game. But in reality, it's binary search problem distinguished as game. Moment you hear higher, lower, correct, your binary search alarm should immediately start ringing because every answer cut the search space into heaven. And that's exactly why the binary search is one of the most powerful algorithms you will ever learn. If this explanation helped you understanding the binary search for the first time, hit the hit and subscribe. Hit like and subscribe and comment the next LeetCode problem you'd like to solve together. See you in the next one.